Now guys, before this video starts, I just want to let you know that if you don't have a pad of paper and a pencil, you should definitely go get one, because this is going to be very complicated. Alright, hey, what's going on guys? It's my Ty Odell Billy here, and today, guys, we are going to be making a 20 subscribers video. Now, honestly, I thought, watch it, 20 subscribers, guys. Seriously. Look, well, 22, used to be 23. Just someone unsubscribed. 2 subscribers, but see? 20 subscribers. That's amazing. Wow. Honestly, it's just, thank you guys so much. Now, let's see when we hit 10 subscribers. Video, Smile, Ty Odell Billy. Very good. Well, that didn't work. Okay, Smile, Ty Odell Billy. 10 subs. Right, so, see? When was it? This January 1st. 2017. I got this on New Year's. This is recorded, well, uploading. But thank you guys for 10 subs. I mean, it does really mean a lot to me, but I know there's probably no chance I'll hit like 15 subs in like the next year or so, because that was 10 subs. 15 subs. Remember, I said there's probably no chance I'll hit 15 subs in the next year. Decimals? Because you gotta solve. Now here, what did I do here? Okay, what's going on guys? It's my Ty Odell Billy here, and today we're going to be working on MathCon, and the reason why is because we're celebrating we hit our goal of 15 subscribers. Here, I'll even show you. Oh wait, no, I can't. Sorry guys. Sorry. But right now we are dividing decimals. Because you gotta solve it. Does this look familiar? Oh yeah. Time to do some MathCon. Now guys, this is gonna be a daily series on my channel till the MathCon thing. Now you guys are gonna be like, yeah, really? This is all you're gonna be doing just because of math? No, math is not fun, math is not stupid, and 2, good cause. I'm going to Chicago because I'm smart. Hopefully you vlog up. And 3, don't worry guys, I will be posting a gaming video every day. Hopefully. Gaming video and MathCon video. So yeah. Sorry. But here we're gonna be looking at simplifying rational expressions. Cause that right here. So yeah, let's go.
When we first started learning about fractions or rational numbers, we learned about the idea of putting things in lowest terms. So if we saw something like 3, 6, we knew that 3 and 6 share a common factor. We know that the numerator, well, 3 is just 3, but that 6 could be written as 2 times 3. And say, since they share a common factor, the 3 in this case, we could divide the numerator by 3 and the denominator by 3, or we could say that this is just 3 over 3, and they would cancel out. And in lowest terms, this fraction would be 1/2. Or, just to kind of hit the point home, if we had 8 over 24. Once again, we know that this is the same thing as 8 over 3 times 8, or this is the same thing as 1 over 3 times 8 over 8. The 8's cancel out, and we get this in lowest terms as 1/3. The same exact idea applies to rational expressions. These are rational numbers. Rational expressions are essentially the same thing, but instead of the numerator.
Okay, that's good, because this thing is tough, even for me. Sure, some of you guys know that, but I don't, so I'm going to be learning, and hopefully you guys are too. Yes, gaming video will come out.
Numerator being an actual number and the denominator being an actual number, they're expressions involving variables. So let me show you what I'm talking about. Let's say that I had 9x plus 3 over 12x plus 4. Now this numerator up here, we can factor it. We can factor out a 3. This is equal to 3 times 3x plus 1. That's what our numerator is equal to. And our denominator, we can factor out a 4. This is the same thing as 4 times 3x. 12 divided by 4 is 3. 12x over 4 is 3x. Plus 4 divided by 4 is 1. So here, just like there, the numerator and the denominator have a common factor. In this case, it's 3x plus 1. In this case, it's a rational, it's a variable expression. It's not an actual number, but we can do the exact same thing. They cancel out. So if we were to write this rational expression in lowest terms, we could say that this is equal to 3 over 4. That's equal to 3 over 4. Let's do another one. Let's say that we had x squared. Let me see a good one. So let's say we had x squared minus 9 over 5x plus 15.
Okay, guys, I'm going to try to solve this. But for now, plug in x as 5. Plug in x is equal to 5. Let's just pretend that. So x that necessarily won't work, but you know. 2/5. Does that make sense? Probably does.
Over 5x plus 15. So what is this going to be equal to? So the numerator, we can factor. It's a difference of squares. We have x plus 3 times x minus 3. And in the denominator, we can factor a 5 out. So this is 5 times x plus 3. So once again, common factor in the numerator and in the denominator, we can cancel them out. But we touched on this a couple of videos ago. We have to be very careful. We can cancel them out. We can say that this is going to be equal to x minus 3 over 5, but we have to exclude the values of x that would have made this denominator equal to 0, that would have made the entire expression undefined. So we could write this as being equal to x minus 3 over 5, but x cannot be equal to negative 3. Negative 3 would make this 0, or it would make this whole thing 0. So this and this whole thing are equivalent. this is not equivalent to this right here, because this is defined at x is equal to -3, while this isn't defined at x is equal to -3. So to make them the same, I also have to add the extra condition that x cannot equal -3. And so likewise over here, if this was a function, if this was, let's say this was, we wrote y is equal to 9x plus 3 over 12x plus 4, and we wanted to graph it. When we simplify it, the temptation is, oh, well, we factored out a 3x plus 1 in the numerator and the denominator. They cancel out. The temptation say, well, this is the same graph as y is equal to the constant 3/4, which is just a horizontal line at y is equal to 3/4. But we have to add one condition. We have to exclude the x values that would have made this thing right here equal to 0. And that would have been 0 if x is equal to -1/3. If x is equal to -1/3, this or this denominator would be equal to 0. So even over here, we'd have to say x cannot be equal to -1/3. That condition is what really makes
Okay, so we go domain. X plus 1 equals x over x minus 7. Well, if x equals -7, then that'll be -6 over -14. So that is a domain. -1, that would make it 0 over -8, which would not make sense. 1, that would make it 2 over 1 minus 7 is -6. That wouldn't work. And x does not equal 7. 7 minus 7 is 0. So, what? Is it 1? No. No. It's 7. Hold on. I thought... Yeah. So... Oh, x does not equal 7. Okay, next question. 3x minus 7, 2x minus 1. Cancel out, so it's 1x minus 7 over 1. Okay, x cannot equal 7. So 14 plus 1. Yeah, so 15 over... No, so x can equal 7. 14 over 3 is 7, 24. 24 minus 7 is... No, 21, 14, 15, so that would work. -1. So, -2 plus 1 equals -1. And... Hold on, so... And then -3 minus... So, -10 over -1, which is just -10, so... No, that's not right. Hold on. I'm dumb, so divided by -1 is 10. I'm an idiot. Okay? -1/2, would that work? So -1/2 would make this 1, right? No, that would make it -1, and -1 minus 1 is 0. Domain. Oh, Jesus! Here we go. What is the domain of 2x minus 3, x times x plus 1? So if x equals 0, then 0 times 0. Okay. Wait, but there could be other answers. So x equals 0. So this we know is not correct. Because negative 3 over 0. So 0 we know is one of them. 0 and 1. So 1 plus 1 is 2 times 1 is 1. Is 2. Yep. And then 1 is 2 minus 3, negative 1 over 1, which is negative 1. So, no, negative 1 over 2, which is negative 1 half. So, negative 1. What would negative 1 do? So, negative 1 plus 1 is 0. Negative 1 times 0 is 0. So, it's 0 and negative 1. Oh, yes, I can. Only. Let's try 3. 3 squared equals 9. Yeah, 3 squared is 9. Well, 3 minus 3 is 0. Don't think that works. Negative 8. 8 minus 2 is 5. 8 squared, 64 minus 2x, which is 48. Yeah. 48 minus 8 is 40. Hey, hold on. I think the 0 will be fine. Oh, it's only for the denominator, so I'm an idiot. So 0 over 9 minus 2x is 9. So negative 8. 0 over negative 8 is 0 divided by negative 8 is 0? I don't know. 0 divided by negative 8. 0. Should have guessed. So 0 over negative 8 is 0. So that would work. 3 would also work. So here we go. Negative 2 and 4. I'm going to take a guess that it's that because it's nothing else. See, I didn't even have to do math, but since I'm a genius, we're going to do this. So x minus 3, x squared, plus minus, pencil, x squared minus 2x, x squared minus 2x. And by the way, x squared and 2x are different things. Hold on, what's that fancy symbol? Yo, what's that fancy symbol? What is plus over not an over. Gosh, dang it, I don't even know what that sign means. Wait, what does what does it mean? Sick. Such. So Jamble. Jamble? I don't think that's a real word. We're gonna go like that and then right left. Okay, Emily, stop. Stop, I don't want your product now. Just that. It's on Glamoury blog. Well, I don't know what it means, so we're gonna have to deal with it. Okay, so that's 8 plus 2 squared would be -4, or 2 squared. So it's -4. So this is the domain. So I'm a genius. So -2 squared plus 4 equals 0, and then -2 squared, -2 plus 2 equals 0. So you have 0 over 0, which is 1. I'm probably on. So we know that that is undomainable. Wait, what? That's a domain. So x plus 2. Okay, so 2 would work. So it's -2. Done. I don't... What the heck is this fancy symbol? It's -2. How would 2 be correct? It's all real numbers? Hold on. Oh, I don't get that, sir. Next question. Simplifying. So 6x plus 20 and 2x plus 10. 2x plus 10. Well, we can simplify both x's, so 1x, which is equivalent to x plus 10, is equal to 3x plus 20. Simplify that. So you got x plus 1 over 3x plus 2. So, yeah, 3x plus 2, but x cannot equal 0. Is that correct? Well, this is correct too. But it's simplified. So 3x plus 2 could work, but the double x, 3x over x is 3, right? Yeah, it's not 3x, it's 3. Why you do this, Con? Anyway, so 3x squared over 4x squared minus 5x. So how do you get that? I don't know. You ask me. Oh my goodness, we're not even halfway done with this video. Because we got an hour. Long hour. This is gonna be tough. We can't switch it. Or we could. Hold on. Why don't we make this problem instead of x squared minus 3x cubed, squared, why can't we make it negative 3x squared plus x3? I'm a genius. So there we go. Okay, so how do we simplify this? I don't know. So negative, first question, what is negative 3x squared negative 3x squared divided by 4x squared. I'm guessing it's 12x squared or 12. 0.75. Negative 0.75. I don't know how I'll get that, but they got it, so I'm going to go with that. Negative 0.2475. So, we got negative 0.75. No, that won't work. Honestly, what grade is this? By the way, I'm actually doing extra. Con doesn't want me to do this. Math con. Okay, I need help. I'm sorry, guys. I'm cheating. Why didn't I do that? I'm an idiot. Anyway, guys, I'm actually trying to solve this problem this time. Well, we have 2x2 being cancelled, right? No. 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 Ow, Daddy, you scared me. Anyway, so here we go, guys. If you're still watching, you've been spending a long time watching 30 minutes of me doing math, but anyway, we're going to try to solve this problem. If you don't have your pen and paper out and you're trying to see me fail, that's okay, because, you know, probably want to do that. Okay, anyway, so how do we factorial this out? Okay, first, let's see. Factor the numerator and the denominator. Oh! So it equals x plus 1, x minus 1. X plus 1 times x minus 1. And x minus... How do you get that? X minus 2, x minus 2, and x minus 3. I mean, x minus 1. Well, in that case, can't you make... Wait a second. Can you cancel out the x minus 1s? So we've got x minus 2 over x minus 1. Oh my goodness. Guys, I think we're getting this. X minus 2 over x minus 1. So we can't factor out the x's because it's minus. But if it's multiplication or division, I think we could. Or cannot. So the answer is... Wait, did I do miscalculations? It's x plus 1. So it's this. X minus 2. Hold on, so it's x minus 2 plus 1 for x not equal 1. That's wrong. They're both wrong. If those two are wrong, then this is right. Well, how would this be? Hold on, we can cancel. Wait, but how would x not be able to equal 1? 1 plus 1 minus 1. 2 times 2 is 0. Oh, so is this for x not? Oh, I did not know that. Okay, thank you so much, Colin. Here you go. Anyway, let's go on to x squared minus 2x minus 15, x squared plus x minus 6. Okay, help me first step, only first step. Factor the numerator and denominator. How do you do that? So x minus 5 times x plus 3 over x plus 3. By the way, if you guys want to take a break and get some popcorn, maybe you watch your new show that you just found. Can't we switch these around? So it's x minus 5 times x minus 3. Hold on, yeah, I'm getting this. X minus 5 plus x minus 3 over x minus 2 and x plus 3, which means we can factor out the x plus 3's. So we got x minus 5 over x minus 2. So x cannot equal 2. So x cannot equal 2. That's for sure. X minus 5 over x minus 2. We can't factor out the x's because, hold on, we got somewhere. Why can't it equal negative 3? Hold on, why could, well, that's understood, but why can't it equal negative? Oh, because that would make this value 0. Oh, okay, so it can't equal negative 3. So it can't equal negative, or x, since it's understood, x minus, x not negative 3, and I'm right? Yeah. X minus 5. Yeah, guys, we got it right. X minus 5 over what? X minus 2. Well, you got that part right. Yeah, good job, guys.
So I have a rational expression here, and what my goal is to simplify it. But while I simplify it, I want to make the simplified expression be algebraically equivalent. So if there are certain x values that would make this thing undefined, then I have to restrict my simplified expression by those x values. So you could pause this video and take a go at it, and then we'll do it together. All right. So let's just think real quick. What x values would make this expression undefined? Well, it's undefined if we try to divide by 0. So if x is 0, 14 times 0 is 0, it's going to be undefined. And so we could say x cannot be equal to 0. For any other x, we can evaluate this expression. Now let's actually try to simplify it. So when you look at the numerator and the denominator, every term we see is divisible by x, and every term is divisible by 7. So it looks like we can factor 7x out of the numerator and a 7x out of the denominator. So the numerator we can rewrite as 7x times, if you factor 7x out of 14x squared, you're going to be left with a 2x. And then you factor a 7x out of 7x, you're going to be left with a 1. And one way to think about it is we did the distributive property in reverse. If you were to do it again, 7x times 2x is 14x squared. 7x times 1 is 7x. All right? And now let's factor 7x out of the denominator. So 14x could be rewritten as 7x times 2 times 2. And remember, I want to keep this algebraically equivalent. So I want to keep the constraint that x cannot be equal to 0. And so we divide the numerator and the denominator by 7x. Or one way to think about it, you could divide 7x by 7x and just get 1. And we are left with 2x plus 1 over 2. Now, if this was the original expression, x could take on any value. But if we want it to be algebraically equivalent to our original expression, it has to have the same constraints on it. So we're going to have to say x does not equal 0. And this is it's a very subtle but really important thing. For example, if you defined a function by this right over here, the domain of the function could not include 0. And so if you simplified how you define that function to this, if you want that function to be the same, it needs to have the same domain. It has to be defined for the same inputs. And so that's why we're putting the exact same constraints for them to be equivalent. If you got rid of this constraint, these two would be equivalent everywhere except for x equals 0. This one would have been defined for x equals 0. This one would not have. And so they wouldn't have been algebraically equivalent. This makes them algebraically equivalent. And of course, you could write this in different ways. You could divide each of these terms by 2 if you like. So you could divide 2x by 2 and get x, and then divide 1 by 2 and get 1/2. But once again, we would want to keep the x cannot be equal to 0. Let's do another one of these.
watch this last one.
So it's a slightly hairier expression, but let's do the same drill. Let's see if we could simplify it. But as we simplify it, we really want to be conscientious of restricting the z's here so that we get an algebraically equivalent expression. So let's think about where this is undefined. We could think about where it's undefined by factoring the denominator here. And actually, let me just, so this is going to be equal to, actually, let me just do the first step where I could see, well, what's a common factor in the numerator and the denominator? Every term here is divided by z squared, and every term is also divided by 17. So it looks like 17z squared can be factored out. So 17z squared can be factored out of the numerator, and then we would be left with, you factor out a 17z squared out of 17z to the third, and you're going to be left with just a z. 17z squared, you factor a 17z squared out of that, you're going to be left with just a 1. And once again, you can distribute the 17z squared, multiply it times z, you get 17z to the third. 17z squared times 1 is 17z squared. All right. All of that is going to be over. We want to factor out a 17z squared out of the denominator. 17z squared times. And so 34z to the third divided by 17z squared. 34 divided by 17 is 2. And z to the third divided by z squared is z. And then we have minus 51 divided by 17 is 3. And z squared divided by z squared is just 1. So we'll just leave it like that. And so over here it becomes a little bit clearer of, well, one, how we're going to simplify it. We're just going to divide 17z squared by 17z squared. But let's be careful to restrict the domain here. So we can tell if z is equal to 0, then 17z squared is going to be equal to 0. It would make the denominator equal to 0. And we could see that even looking here. So we could say z cannot be equal to 0. And what else? Z cannot be equal to whatever makes this 2z minus 3 equal 0. So let's think about what makes 2z minus 3 equal to 0. 2z minus 3 is equal to 0. You can add 3 to both sides, and you would get 2z is equal to 3. Divide both sides by 2, and you would get z is equal to 3 halves. So z cannot be equal to 0, and z cannot be equal to 3 halves. So that's how we're going to restrict our domain. But now let's simplify. So if we simplify it, these two cancel out, and we are going to be left with, z plus 1 over 2z minus 3. And we want to keep that constraint. z cannot be equal to 0. And actually, this second constraint is redundant because we still have the 2z minus 3 here. If someone were to just look at this expression, they're like, well, the denominator can't be equal to 0, and so z cannot be equal to 3 halves. So this is still, if we just left it the way it is, if we don't even have to rewrite this, that would be redundant, since looking at this expression, it's clearly not defined for z equals 3 halves. So there you go. If someone asked you for what values is this expression not defined, well, then you would also include that. Actually, let me just write it. It doesn't hurt to be redundant. Z does not equal 3 halves. But this constraint right here is really important because it's not obvious by looking at this expression. This expression by itself would be defined for z equals 0. But if we wanted to be algebraically equivalent to this one and that one, it has to be constrained in the same way.
Because I'm taking a break. 45 minutes is enough for once. Anyway, guys, that's going to be it for today. I hope you guys did enjoy. If you did, hit that like button down below. Let's try to get a couple likes, because I don't think you guys would probably pass 10. And also, if you guys want, do want, what is it? And also, the gaming video will be coming out maybe in an hour or so be prepared.